Okay, so today's lesson has to do with direct, and indirect inverse variations. Okay, so direct variation. Here it is, y equals kx. And in our reading, we talked about the fact that it's the exact same thing as y equals mx. Y equals mx, right? And we know that if we have a line like that, we know that it starts at 0, so we can put plus 0. And it's going to have up 1 over 1 or whatever it happens to be, but it's going to be straight. So it has to start at 0, and it always is straight, okay? Always goes to the origin, and it's always straight, okay? So example 1, let's do it. It says, if y varies directly with x, when x is 14, when y is 14, x is 3.5. So let's graph it, okay? So let's see, I might have to go by 2s to make it fit. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, right? So at about 3.5, I'll have a point at 14, okay? Well, that's not much. If I'm going to draw a line, I need another point, don't I? I need another point. 0, 0, right? You guys agree with 0, 0? Okay. So here's my line. Okay. So how do I find the equation? Well, we're going to use this little formula, y equals kx, because we said it varies directly. Okay, so I'm going to use this little equation. Okay, and if I put 14 in for y and 3.5 in for x, I'll be able to find k, won't I? If I put 14 in here for y, if I put my 3.5 in for x, I could solve for k, couldn't I? What am I going to do to solve for k? Yeah, just divide, right? Anybody have a calculator handy? Because I obviously don't. Did you get 4? Yeah, it'd be 4. Yeah. So k is 4. So what's our equation? Everybody okay on what I did? That makes sense? My equation is just y equals 4. Oh, come on. 4x, right? There you go, because I put the 4 in for k, and there it is. Thumbs up? So all I did was I used their little equation. They said it was direct variation. I put in the 14 for y. I put the 3.5 in for x, and I solved, okay? Right? Okay. Example 2. Inverse variation, okay? So there's two ways to write it. This is the way I like to write it, x, y equals k. But another way is to write it as, or we could write as y equals k over x. Okay, that's the same equation, but the difference is I just, in a sense, solved for y. I brought the x in, okay? Same equation. So, example 2. If y varies inversely with x, when y is 2, z is x. Well, I can graph that point. So I go 3, 1, 2, 3, and then 1, 2. Okay, I got a graph there, right? Nope, I'm wrong. 2, 3. Doggone it, got it backwards. It's okay. I'm going to leave that point there because that's going to be there anyway. So, how do I find k? Well, let's look at our equation. We have x, y equals k, right? My little equation. So if I plug in 3 for y and 2 for x, right? So if I go 3, 4, 2 for y and 3 for 2 for x, 3 for y. What's k equal?
6.
Everybody agree? So let's rewrite it. Let's take my equation, let's just write it. So it's going to be x, y equals 6. Now, what the heck does that mean? Well, it's like something times something equals 6. You with me? So something times something. We don't know. X and y are variables, right? So we already know. So let's graph it. I already know that 2 times 3 is 6. And I accidentally, kind of on purpose, put 3 times 2 is 6, right? So let's do the rest of this graph. What else could I put? What times what makes 6? 6 and 1. 1, 2, 3, 4, 5, 6 and 1. And what else?
1 and 6.
1 and 6. 1 and 1, 2, 3, 4, 5, 6. Yes. What else? Yes. So there's some numbers over here. Hint, hint, hint. -1 and -6. 1, 2, 3, 4, 5, 6. And? -2 and -3, and And there you go. That is the graph of an inverse variation. When you said 12 and 1/2, who said 12 and 1/2? 12 and then 1/2? Totally correct, right? Totally correct. And that would be the really small ones right over here, right? Okay, good. So here's the thing. If straight goes through the origin, it's going to be direct. Straight through the origin, direct. If it curves like this, it's going to be inverse because you've got two numbers multiplying. Okay. Now, example 3. So the area of a triangle varies jointly as the base and height. Okay, we actually already did this one, but let's set it up their way. Okay. So jointly, so we're going to go A equals K times B times H. Jointly. Okay. So we gotta have extra variables. Okay. Area is equal to jointly with the base and the height, okay? So I already know K's got to be 1/2, but let's prove it, okay? It's got to be 1/2, right? We know it's 1/2. So if I prove it, we'll say, okay, when we've got A is 12, when B is 6, and H is 4, okay? So we plug everything in. So if we need to find K, I already know K is 1/2, but let's say I didn't know that. Plug stuff in, plug the 12 in for A, plug the 6 in for B, and the 4 in for H. Okay, so I just set it up. I knew it was a direct variation. So I'll get 12 equals K times 24, right? Right? Divide by 24, divide by 24, divide by 24. I get 12 24ths, which is what? Exactly. So we already knew that, right? We already knew K had to be 1/2, so K is 1/2. So my formula really should be A equals 1/2 base times height. So again, let me say it for the third time. This entire unit is going to be to find K. Does that make sense? All the way through, you're going to find K and rewrite it. Find K and rewrite it. Now we can actually use it. So we have a formula. I'm going to circle my formula. I'm going to use my formula. So let's use my formula. So now it says find B. So my formula is A equals 1/2 base times height. Let's use our formula we just made. So I'm going to put 36 for A, right? I just made a formula. Let's use my formula. Equals 1/2. The base, I don't know, times B times H, right? H is 8. Let's put 8 in there, okay? So I put the 36 in for A, 1/2. The base, I don't know. The H is 8, okay? So probably the easiest thing for me is to take half of 8. You okay with that? That'd be faster. Half of 8 is 4. So 36 equals 4B. And then what are you going to do? Divide. B is 4 divided by 9 is, I just said the answer. 4 divided by 36 is 9. There we go. I said the answer before I even said the problem, huh? Man, I tell you. Okay, ready? Turn the page. Easy. Okay. So the goal is to find K, right? Now, identify each variation, okay? So, here's the easiest way to do it. If they multiply to make the same number all the way through, it's going to be inverse. So inverse, if they multiply to make the same numbers. But 3 times 9 is 27. 8 times 24 is not. That's 300. So this one's not inverse. It's not. It can't be inverse, right? But it might be direct, right? So how could I tell? Well, see, it goes up by 5. When it goes up by how much? 9 and 24. Alyssa, anybody got a calculator handy? Oh, I do. Hold on. All right. So 24 minus 9. It went up by 15, okay? It went up by 2 when it went up by 6, okay? So remember slope? Remember slope? So if it goes up 15 over 5 or up 6 over 2, up 15 over 5 or up 6 over 2. What's the slope of this thing? 3. So I think this thing's got to be direct variation. So I go and look at my formula. So I'll go, okay, I think it's direct variation. I find my formula for direct variation, right? Use my notes. Use your notes. So I think it is. So I'm going to go y equals, so I'll do on the side. I think it's a y equals kx. So let's find out what k's got to be. So pick any point. How about the easy point, right? So we got to plug it. We got to plug it in. Let's pick the easy point, right? I could pick any of these, but let's pick the easy one. So if I plug in 3 for x, and I plug in 9 for y, and I solve for k, what do you get? Yeah, which is kind of what I thought it was, right? So it's got to be y equals 3x. Now, am I sure? Am I positive? Well, check your numbers, right? If I plug in 8, what do I get? If I plug in 8, what do I get? Yeah, if I plug in 10, what do I get? There you go. Now, does it go through the origin? How can I check that? It has to go through the origin. How can I check that? Yes. If I plug in 0, what do I get?
0.
And so it has to be direct variation. So let's say this one is direct variation. Okay, it's got to be. And that's, yes. And there's my equation, right? So now, what's the next one? So the next one I think is inverse. So to be inverse, I look at my old notes. What is inverse? That times that has to equal some number. So let's see. If I multiply, yeah?
So when you graph that, would it just be a slope 3 over 1?
Yes. Totally right. Yes, 100% correct. So I think this is inverse. So this times this. What is 4.5 times 8? I don't know. 4.5 times... I get 36. 12 times 3? I can do that. 2 times 18? I'm pretty sure k is going to be 36. What do you think?
What is this witchcraft?
So I think I'm going to say x, y equals 36. Because you've got two numbers multiplied by the same number, this one's got to be my inverse variation. Okay?
Wait, will you explain that one more time?
Right, great question, okay? So, here's what happens. Let's look at the equation so you get it, okay? The equation, xy equals some number. So, if you take any 2 points, 3 times 2, what is it? 6. If you take 6 times 1, 6. If you take 2 times 3, 6. 1 times 6, you get 6. If you get negative 2 times negative 3, 6, right? What number do I keep getting? 6, right? So if the x and the y always multiply to the same number, it always gives you the same number, it's got to be this one, which is the inverse, okay? Now take a look. That times that, what's it equal? 36. That times that, what's it equal? 36. That times that was equal 36. So if it's something times something always equals the same number, it's got to be the inverse variation, okay? All right, example number 5. Okay, the time t that it takes for a group of volunteers to construct a house varies inversely, okay? So we'll go t equals, okay? Varies inversely, so we're going to have a k over v. Okay, and I'm going to stop for a second, but I want to go ahead and underline this word, okay? Varies inversely, okay? So if you go very inversely, then I'm going to flip the page real quick. We can either use that equation or this one, okay? The reason I'm using this one is because the way the equation said, t equals. That makes sense? So they're saying time varies inversely of volunteers, okay? K, always K, but you always want to find, always need to find K. That's the key to this whole thing, is finding K. So let's set it up. So if I go, all right, I can do that. So now 20 volunteers, let's go for V, right? Can build the house in 62.5, that's T, okay? So it makes sense. When one gets big, the other gets little. Think about this, inverse. So if I have to build the house all by myself, it's going to take a lot of hours, right? If I have 30 of my buddies, it's a lot, it's going to take less hours. Does that make sense? As one number gets big, the other gets smaller. The more workers I have, the less time it takes. That's inversely varied. So let's do this one. So I'm going to put my 62.5, because that's the number, that's the hours, equals k over 20, because 20 volunteers, and I could solve for k, right? I could solve for k. What do I do to solve for k? Multiply, right? Multiply it up. So what is 20 times 62.5? Is it 110? Yeah, 1,250. So that's what k is equal to. So now I'm going to rewrite my equation. So my equation is this. Here's my equation. I'm going to rewrite it as my equation as t equals 1,250 over v, because I found k, right? So I'm going to rewrite my equation. I know k. So now I can use my equation. Okay, so I made my equation. I found k. You always have to find k. You always have to find k. Always find k first. please always find K first. Guess what you need to find first? K. Do you think I said that enough ways? Guess what you got to do first?
Find K.
Find K, what do you know? Okay, now we found K and we rewrote it, right? So now let's use our new equation. So then the second part of this equation says how many hours, that's T, would be needed to build a house in 50 hours. So how many workers, okay? So I need to get the house done in 50 hours. I'm going to have to hire some people, right? So 50 hours equals my 1250 over V. How many volunteers? Now how do I solve that? Well, I can't divide. Well, yes, I will, actually. You're ahead of me. Actually, you're totally right. You will. I'm going to multiply by V and then divide by 50. How's that? Aaron, you're totally right. So Aaron did a shortcut, but she's smart. So bring up the V right there. And what we write is 50 V equals 1,250. And then, Aaron, what are we going to do? Divide. Totally right. So how many volunteers do we need? I don't know. 1250 divided by 50. We need 25 volunteers to get this house. Okay? So let's take a look at the homework together because it's a little confusing with its words. Okay? So let me highlight what the homework is.
Can I get a homework?
You can. Let me stop the recording.